Actually, no, I won't. No. Okay, so a to the power of 3 divided by a. That's the same thing as writing a times a over a. If I simplify, a to the power of 2. And if I use the exponent law, it's going to be 3 minus 1, which is a to the power of 2. You guys are okay with that? So if I do 3 minus 1, it's going to be a to the power of 2, right? So the answer right here and the answer right here, they match. Yeah? So next one is a to the power of 3 divided by a to the power of 2. So that's a times a times a. Over a times a. So if I simplify, what am I left with? A to the power of 1, right? Or just write a. Using the exponent law, if I do 3 minus 2, what do I get? 1. Are you guys okay with these so far? With these two? Yes, a or a to the power of 1, that's exactly the same thing. You don't have to write to the power of 1, so I can erase that. Okay, a to the power of 3 divided by a to the power of 3. What do I get?
Just a no.
So, let's see. Gone, gone, gone. So that is,
A to the power of 0 is 1.
it's 1. Right? This is 1. Right? Anything you divide by itself, if you do 10 divided by 10, what do you get? 100 divided by 100. A over a, 1. A cube over a cube, 1. So no matter what, as long as you're dividing something by itself, you're going to get 1. Now let's use the exponent law. So that will be a 3 minus 3. What's 3 minus 3? A to the power of 0. So here's something that you probably want to pay attention to. A to the power of 0 is equal to 1. This is a rule that we're going to learn.
What? The rule, right?
That's a rule.
Anything to the power of 0 is equal to 1.
That's correct. Anything to the power of 0 is 1. Okay. A to the power of 3.
So why isn't it just A?
Because if it's a, that means it's a to the power of 1. Right? But it's not.
So can you write a to the power of 0? You have to write 1.
A to the power of 0 is equal to 1.
So it's the same.
It's the same. Now, let's simplify this. What do I get?
A to the power of -1?
Don't speed things up. Okay, so if I divide this and this, this and this, this and this, what do you guys notice here? Where do I have an a left? In the bottom. So I would write this as 1 over a.
Oh.
What?
Oh, yeah.
It is in the bottom. It's 1 over a. Right? Because in the top I don't have anything left, so I have only 1. Right? And then in the bottom I only have a left. Now let's use the exponent law. So I have a, 3, take away 4. What's 3 take away 4?
-1.
So it's a to the power of -1. So a to the power of -1. Remember that these two should be exactly the same. Okay? Let's keep going. Let's do the next one.
So a to the 8 over or 1 over a is
Uh-huh.
equivalent to a negative. So if it was like -8, it'd be 8 over -8. Or sorry, -8 over 8.
It's the exponent is negative. So let's see the next one. It will become clearer with the next one. Okay. So if I have a, actually not the next one. Skip that one. Skip that one. Let's do this one. So a to the power of 3. So that's a times a times a over a to the power of 5. Let's simplify. Gone, gone, gone. What do I have left? 1 over a squared. We are all okay with that? I want to hear a yes. 1 over a squared. Yeah? Because I don't have any more a's in the top, so that's 1. And then the bottom I have a times a, which is a squared. Okay. Now let's use the exponent law. What's 3 minus 5?
-2.
So, 1 over a is equal to a to the power of -1. 1 over a squared is equal to a to the power of -2. What do you think 1 over a3 is going to equal to? A to the power of negative. Right? So what happens is, if you have a negative exponent, we call this flip the base and make your exponent positive. What is your base right here? Your base right here is a over 1. Anything by itself, any whole letter or whole number, right? It's always divided by 1. Okay? So flip the base, it becomes 1 over a, and then you make your exponent positive. Let's look at this. If I'm going to use the exponent law, a 3 minus 7, what's 3 minus 7? -4. Can you write this for me with a positive exponent? So what would it be? 1 over
1 over a4.
That's right. So, flip the base, make your exponent positive.
Always when you have a negative exponent, you
When you have a negative exponent, remember it's a negative exponent that affects
You can only leave it as a negative?
No. The question will always ask you to leave your answer with a positive exponent.
Wait, how can you just switch it? How does that make any sense?
How does that make any sense?
Yeah. You just decide to switch it.
I didn't decide, I showed you that if you actually do the regular simplification, it's 1 over a. If you do exponent law, it's 1 over -1, but we know that these two are equal because I'm following the same rule. Right? Didn't I show you that? I showed you that. You know, if I do exponent law or if I do the simplification, I'm gonna get the same answer every single time. Right? But once I do the exponent law right here, I'm gonna get -1. When I do the simplification, I'm gonna get 1 over a. So that means 1 over a is equal to a to the power of -1. Right? I proved it to you.
So you're just writing it.
Yes, you're writing it in a more proper way. The proper way is with a positive exponent. So this is the proper way. Okay? So if you ever get an answer with a negative exponent, you're gonna have to flip. Are you guys okay with this? So, the zero law, before we, so we need to write the zero law. So the zero law is anything to the power of 0 is equal to 1. So, if you don't believe me, you can use your calculator and plug in any number you wish and put it to the power of 0 and see what your calculator is going to give you. And the reason for that is because I'm dividing the same thing by itself. Anything divided by itself is 1. Are we okay with this? Okay. Now, the other rule that we are going to write is if you have a negative exponent, you're gonna flip the base and make the exponent positive. That's on the other page, on the next page. Can you guys help me with this? What if I have a over b, all of it, to the power of negative n? How can I write this with a positive exponent?
B to the power of n over a to the power of n.
So without doing the other one, so it will be, the answer is right, but I'm just kind of doing this a little bit more. So, I said when you have a negative exponent, what do you do with the base? Flip it. So if I flip a over b, what does it become? B over a. And then what do you do with the exponent?
It's positive now.
Make it positive. Done. Okay? So, Yama, you did one extra stuff, so you distributed that. And I do that just
You can do that or no?
after, yeah. You can. But I just want to show them going from negative to positive. This is not. Okay? So if you have 3 over 2 to the power of negative 5, how can you write that as a positive exponent? 2 over 3
Yeah, and positive 5.
to the power of plus 5. Okay. My advice to you, do not flip until the end. Unless, so let's say if you have something that looks like this negative, don't flip until you have simplified completely. Okay? Like, especially if you have here, right? Don't flip. Do whatever you need to do first. Subtract your exponent, add your exponent, whatever you do to your exponent. Then, if your final answer has a negative exponent, then flip it and put it in the denominator. Okay? So, let me show you this. If I have, let's say, x to the power of negative 3 over x to the power of 5. Okay? I don't want to flip that x to the power of negative 3 yet. What should I do with my exponents first? Subtract them because I'm dividing. Okay? So that's going to be x negative 3 minus 5. You see what is happening? Now that's going to give me x to the power of negative 8. Then now I'm going to write it as 1 over x to the power of 8. I didn't flip from the beginning. There's no need to flip from the beginning. Do your simplification first, then flip if your answer is negative.
But if you flip it, gives you the different answer, right?
No, it doesn't, but it becomes more complicated. Okay? Now, another thing that I want to point out. I just need your attention here. You can do I'll give you time to do the work. If I have this, there's nothing I can do about this, right? There's no way I can simplify this because the top has an x, the bottom is a y, right? Yeah? Yes or no? I can't simplify this, right?
Yeah.
Okay. The only thing I have to do is I have to change that x because that's x to the power of -2. I have to I have to make it positive. So to make it positive, simply you just have to bring it down to the denominator. The y has to stay down there because only x is to the power of -2. So that becomes 1 over x squared y. There's a difference between this and the what you saw right here on the top. What's the difference?
Exponents for both x and y.
That's right. The second one right here, the exponent is negative for both of them. So in this case, I have to flip my whole base and make it y over x to the power of 2. Right? But in the top case right here, right, the exponent, the negative exponent only belongs to the x. So I only have to bring this down to the denominator. This is the only one that gets flipped. Are we okay with this? That's why brackets are an important thing, and you need to know when to use them, and you need to know how to use them. Because you can't put brackets for no reason, right? The brackets mean something. Okay. Another thing. If I have something that looks like this, okay, that's a bit more complicated stuff. What I can do, I can flip first in this case. That's fine to flip first. It's fine to do this. First, and then simplify inside the bracket and then bring the 3 in. Okay? That's what we do. No. It's multiplication, there's no form. You just have to simplify. Use the rule that we've already done. Like if you're dividing, you subtract your exponent. Okay? We'll get to things like this later, like in the worksheet. Okay, you'll see things like this. But for now, I want you to complete these questions. Okay? I will give you the answers on the board so you can check them. Complete these questions. And then if you have, but when you're done these questions, try to do this. Okay? I want to see your work.